we're going to talk about another type of data display. So we talked about dot plots quite a bit in the last chapter, right? A dot plot made it easy for us to see how data was distributed. Histograms are another way that show distribution of data. So a histogram is a type of bar graph, so it displays the data in bars, basically, that shows data frequency in intervals of the same size. So in a histogram, you'll see this, but along the bottom, each bar is going to represent an interval of data. So like 0 to 3 might be 1 bar, and then 4 to 6 might be 1 bar. But they have to be the same size intervals. So like intervals of 3 or intervals of 5 or whatever. And then each bar will represent how many times numbers in that range came up in your data set. So we'll look at what this looks like. The height of each bar in your histogram shows the frequencies of the values in the interval. So if, maybe your interval was 0 to 3. And in your data set, you had a 0 and 3 ones and a 3. That would be 5 numbers in that interval. So your frequency or your histogram bar would go up to 5 because there were 5 numbers in that interval in your data set. Here's an example of a histogram. What do you notice? Raise your hand and tell me something that you notice. Tate.
It's not like the bars aren't for one specific number.
Good. Notice, this is important, and this is kind of a defining feature of histograms. The bars aren't for one number only. It doesn't tell us how many snakes were 3 feet long, right? We only know how many were between 0 and 6. How many snakes were between 0 and 6 feet? Well, 4, because our frequency goes up to 4. Good. What else do you notice, Liam?
This is a comment last week on the games. This is on.
Yeah.
You're right. Yep. Good. So we've sort of seen one of these before. What else, Hudson?
The numbers they each give each other by 6.
Very good. So that's another important feature is there are 6 numbers in each bar. And that in order for a histogram to be correct, it has to go by the same number. So you can't be like 0 to 6, 7 to 27. Like it has to be by the same exact interval for each bar. So these are each by 6. And then it tells us in that range how many pieces of data. So there were 4 snakes from 0 to 6 feet, 3 from 7 to 13, 1 between 14 and 20, and 2 from 21 to 27. Okay? What can we not see on a histogram? What can you not see? Yes.
Like how many are one exact number?
Right. We can't see how many are one exact number. So do we know how many snakes were 3 feet long? No. We only know that in the range of 0 to 6 feet there were 4. We don't know how many were 3, if any were 3, right? So it doesn't give us as exact information as like a whole set of data, but it shows us how data is distributed. Yes. It says display the data in a histogram. So you'll be given a set of data. You'll be given the ranges. Okay, and this is what we're going to use for our histogram. Okay, these are going sets of 3, right? 1, 2, and 3, 4, 5, and 6. So each of these are intervals of 3. And then it tells us a frequency that number came up. So I want you to model this in your notes. You can kind of copy mine, and then I'm going to have you do it on your own in a minute. Start by putting the number of laps along the bottom. So horizontally is where we put our intervals. Along the bottom, we're putting those intervals 1 to 3, 4 to 6, 7 to 9, 10 to 12, 13 to 15. So we sort of separate into intervals, and that's where our boxes will go that show how many were in each of those intervals. Then our frequency goes along the left, so it goes up and down vertically. I did mine by 2s. You can do them by 1s. You can do them by 3s. Just make sure you label. Once we have that done, now we can sort of draw in the boxes with our frequency. So we know that there were 11 people that did 1 to 3 laps. So we'll find 11 and we'll draw our box, right? Up to 11. And then there were 4 people who did 4 to 6 laps. So our next box, and they do touch each other on a histogram. They're right next to one another. 7 to 9, 0 people did 7 to 9 laps. You must have a space for that, and you must leave it empty because it shows the data, right? It shows that there were 0 people, so we need to leave that empty. 3 people did 10 to 12 laps. So that's going to be here. And 6 people did 13 to 15 laps. So that's our histogram. It helps you easily visualize the data and how it's sort of distributed. We can see that there is a lot of people that did 1 to 3 laps, right? That was the most common. Can we see how many people did 2 laps? No, we can't see that exact, but we can see a range of values. Let's interpret a histogram. Here is a histogram showing the winning speeds from the Daytona 500. Okay, so it's a car race. So you can kind of see the data is distributed. More closely between between 140 to about 159. That's where the most winning speeds were, right? Always notice your frequency too. Over on this side, it's going up by 4s. Okay, so just always check that so that you make sure you make the right calculations. All right, let's see what it asks us to do. Which interval contains the most data values? Miles, which interval contains the most data values?
150 to 159.
Very good. 150 to 159. How many values would you estimate are between 150 and 159? If we can't see it exactly, but what would you estimate? What do you think, Kennedy?
Like 21.
I'd say, yeah, maybe about 21. It's just a little bit above that 20 line, but not halfway.
You can see it exactly.
I guess you kind of can, because it would be halfway if it was 22.
Yeah.
So, yeah, 21. Exactly. Good.
Because one kid,
Now, this is going to take a little bit more calculation. How many winning speeds are less than 140 miles per hour? How many winning speeds are less than 140? Will?
9.
Good, because we have 8 that are between 130 and 139, and 1 that is 120 to 129. Those are all less than 140, because that starts here. Meaning that there are 9 winning speeds less than 140. And finally, how many are less than 160? Now we're looking at values. Hold on, let me erase this. Now we're looking at values less than 160. So from here down, Tate, what would you say?
I think it's 29.
29. So this one is 16. Is that right? I think it's going to be more than that, right? More than that. 1 plus 8 plus 16 plus 21. 46. You've got to add all of the columns up that are less than 160. Which would give us 46, I think. Yes.
Would they ask you a question if it was like, are less than or equal to 160? Would they do that?
They can't do that because if they did ask you, you couldn't answer it because we don't know how many are 160, right? Because that next interval starts at 160 but goes up to 169, so we don't know how many are 160. So they can only say less than. Okay? All right. Here's two different data displays. There are better ways to display data based on what you want to learn from the graph or what you want people to be able to see from the graph you choose. So in this case, we have a histogram on the left. And we have a pie chart or a circle graph on the right. They both show us they show us the same things, but they show us different things about the data, right? Which display could you use to see how many students are in the class? Which one of these tells you how many students are in the class? Liam?
49.
But which graph tells you that?
Yellow one.
Think about what it's asking. What are the graphs showing? The number of
The number of people that, the number of push-ups that people can do.
very good. The number of push-ups that people can do. Now, which one, the histogram or the pie chart, shows the number of students? Miles?
Instagram.
The histogram, right? Because we can literally see, 3 students did 0 to 9, 5 did 10 to 19, 10 did 20 to 29, 6, 1. That shows us numbers. Can we see that in the pie chart? No. We can only see the percent of the total and how many push-ups they did, but we don't know how many that is, right? 20% of what? 20% of 100, 20% of 10, 20, we don't know. It doesn't tell us. So the histogram helps us to see total numbers of values. So we would say the histogram is better for seeing the number of students in the class because we could just add up the frequencies. Going back, we're going to still use these two data displays. The histogram versus the circle graph or the pie chart. Which statements cannot be made using the data displays from the last example? So we need to see which one of these are true and which ones are false. Letter A. Can we say that 12% of the class completed 9 push-ups? Let's look back. 12% of the class completed 9 push-ups. What do you think?
You can't say that.
Why not?
It's 0 to 9.
Very good. Okay, this is important. It didn't ask us how many kids completed 0 to 9. It said how many kids completed exactly 9. Is there any way to see how many completed exactly 9? No. So we cannot say that based on either of these. We know that 12% completed 0 to 9, but we don't know how many completed exactly 9. What about 5 students completed at least 10 and at most 19? Let's look back just to check. At least 10 and at most 19, 5 students. Can we say that, Miles?
Yeah.
Yes. We can see that on our histogram. 5 students, at least 10, bless you, and at most 19. So we can say this one for sure with confidence using our histogram. What about at least one student completed more than 39 push-ups? Let's look back. At least one completed 39 or more. Colin? Yes. Again, using our histogram, we can see one student completed 40 to 49, which is more than 39 push-ups. So we can say that with confidence. And then let's look at letter D. Less than a quarter of the class completed 30 or more push-ups. Less than a quarter, 1/4 is 25%. So less than 25% of the class completed 30 or more. So let's look back at our graphs. What did it say? Less than 25% completed 30 or more. 30 or more. What percent of the class completed 30 or more? Well, 28%. Is that less than 25? No. No, that's more than 25. So this is not a true statement. It should be more than a quarter or more than 25%. And we can see that on our pie chart by looking at the percentages. Okay? All right, so just being able to look at and interpret different types of graphs is part of what this is, and just knowing how to make and read a histogram.